Hello everyone, and welcome to Unit 2, Lesson 5, which is the Atomic Theory Review. Remember, we're splitting Unit 2 up into two separate halves. So atomic theory is our first half, periodic table will be our second half. Let's get started. If we take a look at our first 5 questions here, we're trying to match the vocabulary word listed over here with the correct definition from the choices on the right. So I actually think it's easier if we start with the answer choices on the right and kind of work backwards. So a way to refer to an element describes the number of protons in the nucleus. If we're talking about the number of protons in the nucleus, we're actually looking at atomic number. So we can put a letter A with atomic number. Letter B, an atom that has lost some of its electrons, or an atom with more protons than electrons. If you have more protons which are positively charged than you have electrons, then overall the atom becomes an ion with a positive charge. So letter B is going to be our positive ion. Letter C holds electrons in an atom located outside of the nucleus. The name for the area outside of the nucleus that contains the electrons are the energy levels. So letter C is going to be right here. Letter D, an atom that has gained extra electrons or an atom with more electrons than protons is known as a negative ion. That's letter D. And finally, letter E, atoms of the same element which have different numbers of neutrons in the nucleus, that's known as an isotope. So we're going to put letter E right here. Next, in this problem, they're asking us to put our 5 models of the atom in order. So if you think back to Dalton's model of the atom, which is our oldest model, that one just looked like a simple sphere. So we're going to call that number 1. If you think about the next part, the next thing that happened was the discovery of electrons. So we wind up with the plum pudding model, which is this second model over here. Next, we discovered the nucleus, and we come up with this part right here, which is our first picture that has a nucleus in it. After that, energy levels were discovered. So this is our 4th picture. And then finally, we realized that the energy levels were not just circles around the nucleus, but clouds where electrons were likely to be found. So we wind up with our 5th model, which is the electron cloud model. So putting names to all of these, I'm just going to quickly number them once again. So we have 1, 2, 3, 4, and 5. So our number 1 is called the solid sphere model. Our second one is called the plum pudding model. And if it helps, you can cross these out as you go through them. The third one over here is our nuclear model. The 4th one, of course, is our planetary model because it looks like the solar system. And then finally, our electron cloud model. Next, for each of the following, match the vocab word listed on the left with the correct definition from the choices on the right. Particle with no charge that exists in the nucleus of most atoms. The particle with no charge is known as the neutron. So we're going to put an A there. A negatively charged particle that exists in the space surrounding an atom's nucleus, those are called electrons. So we can put a B here. The positively charged particle that exists in the nucleus is the proton. So we can put C up there. The tiny bits of matter, protons, neutrons, and electrons that are the building blocks of atoms, so all of those combined are known as subatomic particles. So we can put a D right here. And then finally, the center of the atom, which contains most of the atom's mass, that is the nucleus. So we can put an E there. Okay, in this next part, we are going to complete this table. So to do this, you'll need a periodic table of your own that has the molar masses for the different compounds. So for the first one, the element sodium. Sodium has a symbol of Na, and its atomic number is number 11. Keep in mind, this column and this column will always be equal to each other. So I can also put an 11 in that space. I colored these three columns green for a reason. And what it's meant to do is help you to realize that protons plus, so if I put a giant plus sign here, protons plus neutrons equal the mass. So if I have a mass of 23 and 11 protons, I know that this has to be 12 neutrons. And finally, for the charge, if I have a charge of positive 1, I'm comparing these two columns here. If I have a charge of positive 1, that means I have more protons than I have electrons by 1. So this must mean I have 10 electrons. In the next example, we have the element sulfur. Element sulfur has atomic number 16. Its mass is going to be 16 plus 16, or 32. And finally, if I have 16 protons and I have 18 electrons, that means I have more electrons, negative charge, and 16 compared to 18 means I have a negative 2 charge. My next example, atomic number 29. That's the element copper. So 29 will also go in this spot. 29 plus 35, that adds up to give you 64. And now when I compare 29 protons to 27 electrons, that means I have a positive charge. And because I have 2 more protons than I have electrons, I have a positive charge by 2. Our next example, we have an element that has a mass of 14 and 7 neutrons. So 7 plus what equals 14. So that answer ends up being 7. So 7 as my number of protons. So that means I'm also going to put a 7 for the atomic number. That is the element nitrogen. Finally, comparing 7 protons to my electrons. I have a negative charge. That means I have more electrons than I have protons by 3. So if I have 7 protons, I must have 10 electrons. Next part, I have 14 neutrons and 13 protons. I'm going to add these two together to give me 27. Notice if I have 13 protons, that number also goes here. Looking at my periodic table, I can see that I have the element aluminum. And finally, if I look at my charge, 13 compared to 10, that means I have a charge of positive 3. Okay, in the next section, we're going to take a look at some of the scientists that were influential in discovering the parts of the atom. So the first person to use experiments to support his idea about the atom, we have a whole bunch of points about atoms, and his representation of the atom looked like a simple sphere. So letter F is going to be Dalton. Next one, identify the electron. His idea of the atom looked like a chocolate chip cookie with negative electrons embedded. That is Thomson. The next one, he used the gold foil experiment to figure out the atom was mostly empty space. Looks like we're going in order here. That's Rutherford. He used information from Rutherford's experiment to figure out that electrons move around the nucleus. His model is sometimes referred to as the solar system or the planetary model. So that's Bohr. And then finally, for the last one, treated electrons as three-dimensional waves, which led to the electron cloud model, and that's Schrödinger. Okay, we're going to finish up reviewing for this quiz by filling in this chart. So first, we're going to talk about the location of the particles, and we'll just go column by column. So both protons and neutrons are located in the nucleus. And electrons, remember, are outside of the nucleus in energy levels. Next, if we look at charge, the charge on a proton is +1. The charge on a neutron is 0 because it's neutral, and the charge on an electron is -1. The next part, the mass of a proton and the mass of a neutron are the same. They are about 1 AMU each. And then finally, the symbol that we use to represent proton is P with a positive sign. For neutron, it's N with a 0. And finally, for an electron, it's E with a negative sign. Okay, so the next time we see each other in class, we will be completing this quiz. If you have any questions, please make sure to send me a message through Schoology or send me an email. Thanks very much. Have a great day.